So chapter 4 is dealing a lot about, talking about something called radians. And we're going to be working with radians quite a bit in this unit. And what I need you to understand is that radians is just another word to describe movement in a circle. So for example, as I walk across this room, I could say something like, this classroom is 36 feet wide. Or what I could do is I could say it's 12 yards wide. Both of those phrases are indicating the same exact thing, a distance, but they use two ways to talk about it. So today, instead of talking about a circle being 360 degrees, we're going to talk about it being 2 pi, radians. So degrees are just a unit of measurement, and radians are a unit of measurement, just like feet and yards are units of measurement. So we're going to use a different word now. And when you get to calculus, pretty much everything is exclusively in radians. That's why this is extremely important. So on the first page, there's a lot of definitions, but we're just going to move and jump around. And the first thing that I want to talk about is this page right here. So this might be page 4 for you or slide 2, I don't know what it is, because I try to space stuff out so we can work with it. We're going to be converting back and forth. So like for example, if you're going from inches to feet, you divide by 12, feet to inches, you multiply by 12. Same thing when you're going from radians to degrees and degrees to radians. And the big idea that I want you to understand is, whatever it is you want to go to is on the top. So for example, notice how in this first example, or this first statement, they want to go 2 radians, and notice how the radians are on top. In the second statement, they talk about going 2 degrees, and the degrees are on top. Whatever you want to go to goes on the top. Super important. Now, I don't use what they have here because I like something that sticks in my head and makes sense to me. So what makes sense to me is when I talk about a circle going all the way around, how many degrees are in a circle? 360. And now, the new thing that we're going to talk about is instead of using 360 degrees, we're going to talk about something called 2 pi for radians. So 360 and 2 pi mean the same thing. They're just different ways to talk about it. So instead of using what you see here in the first statement, even though our notes say multiply by pi over 180, when I do my problems, I always go 2 pi over 360. Because I get that a circle is 360 and I get that that is the same as 2 pi. Can you use pi and 180? For sure. But I always use 360 and 2 pi. So this one would be multiplying by 360 over 2 pi. Now kind of the weird thing is pi acts not only as a number, but oftentimes as a letter. So you know how like we'll have x divided by x is 1? Well, the same is true for pi. Pi divided by pi is 1. So sometimes it helps us, even though it's not a variable, to think about it like a variable. And you'll see what that means as we do some of these problems. Let's try some. First example. Let's change 135 degrees into radians. So I start with 135, and since I'm changing 2 radians, I'm going to multiply by 2 pi over 360. Now, to do this on your calculator, if you're going to use a calculator, bless you, the fastest way would probably be to go 135 times 2 divided by 360, math, enter, enter, and then write a pi on the end. I'm not going to do it that way. I'm going to show you the way my brain works and how I think about this, and then if you want to do it a different way, that's fine. But sometimes things show up on the 9 calculator, so I think it's kind of important to know how to do that. If I multiply these out, I end up with 270 on the top with a pi, and on the bottom I end up with 360. And what I notice is that 10 goes into 270 and 360. That's why they have the zeros on the end. So I can really rewrite that as 27 pi over 36. And then I happen to notice that 9 goes into 27 3 times. Bless you. And 9 goes into 36 4 times. And so my answer in simplified format is 3 pi over 4, or in other words, 3/4 of pi. Now the number pi, you know, is an irrational number, 3.1415, blah, 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 blah. So this is the way my brain works. Again, you can do this on your calculator if you want to. Don't put in the pi, just leave it alone. When you get done, just add it to the end. Second example, negative 100. In order to simplify this, or I should say, change it into radians, I multiply by 2 pi over 360. Now you can do, again, pi over 180. It's the same thing. When I multiply those together, I get negative 200 pi in the numerator and 360 in the denominator. My brain tells me, oh look, 10 goes into both of those things. So now I've got negative 20 pi all over 36. And then I try to find a number that goes both into 20 and 36, the biggest number possible. 4. Okay, so 4 goes in there, and 4 goes in there, negative 5 times on the top. 4 goes into the bottom 9 times. So negative 5 pi over 9, or negative 5/9 pi. If you want to put the pi on the side, that's fine. I often put it on the top. So when I'm converting radians to degrees, notice it says 2 degrees. So if I'm going 2 degrees, I put the degrees on the top, so I multiply by 360 all over 2 pi. Now the thing I love about going 2 degrees is the good news is every single time the pi's disappear. One's on the top, one's on the bottom. Pi divided by pi is 1. So they always disappear. Why? Because we're going to degrees. There are no pi's in the degrees. So then I really get to concentrate on the other stuff. So now I look at this other stuff, and I think about this a little bit differently than I have the other ones. I could, if I wanted to, multiply the 5 and the 360, the 3 and the 2, and figure it out. But here's the way I think about it. Look on the top and you see 360. Look on the bottom and you see 2 times 3. 2 times 3 is 6. 360 divided by 6.
60.
60 times 5. 300. No calculator necessary. What I'd like you to do right now, though, is I'd like you to take your calculator and check it out. Last one on this page, multiplied by 360 all over 2 pi. Holy moly, double bonus. Reminds me of the song, 2 pi don't bother me. You're a what?
What?
I see 360 divided by 3. That's 120. And then don't forget about the negative sign. You're done. Negative 120 degrees. Because on the test, this will be on the test, and like everything I do is on the test. And one of the things I want to tell you is you have to remember this formula. Okay, it's a memorization thing. So this formula right here, where they talk about the arc length, S equals R theta, is something you have to memorize. But I also want you to remember something super important, is that your angle has to be in radians, or you cannot use this formula. Your angle has to be in radians, or you can't use the formula. Make sure you star that. That's very important. So the arc length is S. That is your arc length. S. And all I have to do is take the radius times the angle. That's it. So what they're talking about is if I had a circle and I want to find out how far it is around that circle, or even maybe even a small piece of that circle, like maybe right here. To find that arc length, I just take the angle measurement of that arc. How far around did I go? Was that 20 degrees, 30 degrees? But put it in radians, and then multiply by the radius. Okay, so let's try a couple of examples. In example number 1, it says find the length of the arc. Oh, that's the purple junk. So I start out with writing down S equals R times theta. Oh, and let's see. They tell me that I'm looking for the arc length. That's this. They tell me the radius 40. That's this. And they also tell me that the angle is 135. That's this. So I start plugging some stuff in. I'm looking for the yellow highlighted thing. The radius they tell me was 40. And then the angle they tell me was 135. And if I multiply those two things together, I should end up with my answer, correct?
No.
Why?
Radius has to be, angle to be in radians.
The angle has to be in radians. So if you just multiply those two numbers, you're done. Game over for you. Has to be in radians. So I also have to multiply all that stuff by the conversion that we just got done learning. I want to go 2 radians, so 2 pi goes on the top, 360 goes on the bottom. The best way to do this on your calculator is to go 40 times 135 times 2 divided by 360. You'll get a number. So this is 270, 270.
You get 30.
30?
30.
Okay, 30. Don't forget about the pi. Don't forget about the pi. The numbers all together produce the 30, and then there's also pi, 30 pi. Remember, pi is roughly 3.14. So really, this is 30 times 3, somewhere over 90 for the arc length. That's it. Be in centimeters, of course, because that's the label, but that's how you do it. I want you guys to try the second one. Now, believe it or not, no, not or not. Believe it, this is probably the shortest question you'll ever get on a test. It says S equals R theta, because we're talking about arc length. They give me the radius is 22. That goes here. They give me an arc length of 10. This goes here. Find the angle. So if I find the angle, I need to plug in my numbers first of all. So in the pink, that was a 10. In the yellow, that was a 22. I have a theta. In order to solve this, I divide both sides. 10 divided by 22 is the same as 5/11ths. 5/11ths what? No. I'd like to make fun of you individually.
Oh.
So the crazy thing in number 2 is because you're looking for the angle, when you get your result, this is already in radians. Whereas in the first example, we started in degrees. There does not have to be a pi to be in radians. In fact, if you check out to see what 1 radian is, you could see that it's roughly 57 degrees, which is a transition to what we're going to do next. So we've done 2 out of 5 slides. Go back to slide number 1.